So my name's Colin, and I make a living selling a Lisp editor, which is kind of an unusual thing to do these days. So it's called Cursive, and it's an editor for Clojure code. So it's been around for a while. I've been working on it for a couple of years now. My first public beta was in October of 2013. I then promptly had a daughter, so it took me 2 years to get to a 1.0. But even when it was in beta, it became very popular really quickly. I think people were quite interested in having an alternative to Emacs, and so it quickly became the second most used development environment for Clojure after Emacs. So it's a plugin to IntelliJ at the moment. You do need to download IntelliJ and install Cursive into it, but IntelliJ has a free and open source community edition, so, and that works fine with Cursive. You actually don't need to pay for IntelliJ to use Cursive at all. And it will eventually be a standalone IDE as well. So IntelliJ is now essentially an IDE building platform, and then the Java support is just built on top of that, as are all the other IDEs that JetBrains have done, so the Python and Ruby and everything else. But I do make my living doing this, so if you're using Cursive commercially, you will have to pay me some money. But I think it's fairly reasonably priced, hopefully. And I do also offer a non-commercial license. So if you just want to use Clojure for non-commercial stuff, open source work, personal hacking, learning Clojure, academic work, that sort of thing, it's all free for that. So you can just go to my website and download a free license and use that. So this is the data from the latest Clojure community survey. Hopefully you can read that. It's a little bit small, but so basically Emacs is still the most commonly used editor for Clojure code. About 50% of users. This is data from the beginning of this year. And Cursive was a little bit under 30%, it was 29% at the last one, then Vim was 10%, and then all the sort of standard other editors, Atom and VS Code and things like that, they all have reasonably good Clojure support these days, but not many people use them for their day-to-day work. So it's getting fairly consolidated in mostly Emacs and Cursive now. So I want to talk a little bit about what makes Cursive different from a technical point of view to the other editors. So the other editors in that list are really what I would consider to be REPL-based editors. So they're really just text editors. They actually don't understand Clojure at any really kind of fundamental level. And the way they work is that they actually provide all the editing functionality by introspecting a live running system over a REPL connection. So the way this usually works is you start your editor, you start your application with a REPL server running in it, and then you connect your editor to that running system, and then as you do things in your editor, so say you want to get the documentation for a function, what the editor will do is it will go out to the running system over the REPL connection. It will introspect the function that you're asking about. And all this data in Clojure is reified at runtime. So functions actually contain their documentation at runtime, and they also contain things like source location. So if you want to navigate to the definition of a function, something like Emacs will go out, and it will interrogate the running system. This function, where was it defined? Which file was it defined in? What was the source location? And then it will take you there. So this is very accurate for all the information that does actually get reified at runtime, and at Clojure this is quite a lot. And obviously, in Clojure and any Lisp, you can do quite crazy things in your source code, but the application that's actually running is kind of like the ground truth, right? By the time you've actually compiled and run your code, the application is like the kind of definitive source of what that's actually going to do in the end. So these systems are very, very accurate for anything that actually does exist in runtime. But that's not everything, so Clojure does have some elements that don't actually make it into runtime in any meaningful way. And obviously this does require the application to be running as well, so you get no editor support at all if you don't have something running. So the workflow is normally you start your editor, you start your application, and the two are sort of in this symbiotic kind of relationship. But people really like the experience this gives you. You sort of get this experience that your application is kind of like a living thing that you're molding in real time, and it's this real sort of interactive feedback loop. So you work on a little bit of code, you send it over to your application, you try it out to see if it works, you can poke around with it a little bit, and then once you're satisfied that it's working, you move on to something else. So one other thing with these editors is they only have a very loose concept of a project, so they're really mostly file-based. And one thing that you lose with that is you lose the ability to actually provide a meaningful project-wide index. That actually becomes quite hard. It's not impossible, and Emacs, some of the Clojure support in Emacs does have some support for this, but it is quite much more difficult. So by contrast, Cursive actually works by analyzing source code. So again, because it's built on IntelliJ, IntelliJ has a very, very strong project model. So IntelliJ, and thus Cursive, it's not something you're ever going to edit a single file in, basically. All your editing actually happens within within the construct of a project. And one thing this does actually allow is it does allow a full project-wide index of all sorts of things, which allows some really interesting functionality, lots of nice navigation, all the documentation lookup and stuff like that. That all happens on the IDE side, and it's all done by the source analysis. And this actually allows indexes to be created and things to be manipulated that actually don't exist in runtime. So things like keywords in Clojure don't exist in the runtime in any meaningful way. And things like reader macro forms as well. So Clojure has a lot of these shorthand forms that are later expanded out into built-in forms during the actual code reading. So systems that intersect runtimes really struggle to provide these because when you're using your editor, you're not actually thinking always about what's actually in the runtime. You're thinking about the surface syntax, like the user, that's what they're actually working with normally. And sometimes that can be difficult. And by indexing source code, Cursive can actually provide really good support for those. And then one other really major feature that it allows is that because Clojure and ClojureScript, so they're two different dialects of Clojure, so Clojure compiles to the JVM, ClojureScript compiles to JavaScript. The source code is almost the same. There are some differences, but they're very, very similar. So most of Cursive's functionality actually works completely transparently for both Clojure and ClojureScript. And this is something that REPL-based editors struggle with because the Clojure and ClojureScript REPLs are quite different in quite fundamental ways. So they really end up having to re-implement quite a lot of the functionality for ClojureScript. So I want to talk a little bit about the motivation of why I actually started working on Cursive and why I might like this. And I apologize in advance, I'm going to say nice things sort of in relation to Java. So why might you want to use IntelliJ? And here I am really talking about why you might want to use IntelliJ for Java. So IntelliJ does have this kind of base platform and then a bunch of different IDEs built on top of it, but Java is by far the most mature IDE product that they offer. It's been around for well over a decade, and it's had a lot of people, a lot of really smart people working on it for a really long time. It's a really complete mature product. And so it actually has real syntactic analysis of the code. It'll actually go out and it knows, again, because it has a strong project model, it knows what all the code in your project is. And it will go out and it parses the whole lot. So it creates, lexes and parses all the code. It builds an AST for each source file. And it links those together in such a way that really what it's doing is it's building an AST for your entire project. And this allows a lot of really, really interesting functionality. So IntelliJ is quite famous for its refactoring. It actually started life as a refactoring product before it was an IDE. And the refactoring is a really intrinsic part of the workflow when you're working on Java with IntelliJ. The navigation, again, is totally flawless because it understands everything. So you can navigate between your program elements in quite sophisticated ways, and it all just basically works perfectly. It has a system of inspection, so it can actually run static analysis over your code live in the editor while you're working on it. And it can also propose fixes as well. So the inspections range from quite primitive things sometimes, just like checking naming conventions. Did you start your class name with an uppercase letter and your local variable names with a lowercase letter? They're quite trivial. But then that goes all the way up to running full data flow inspections over your program using a technique called symbolic execution, and it can actually tell you this conditional through this really complicated piece of code always turns out to be true or false. So it has a very, very deep knowledge of Java, and it provides, in a lot of ways, much more sophisticated analyses that even compilers do these days. And it also has intentions. So intentions are kind of you can think of them as sort of like micro refactoring. So, a little block of code, you might want to change it in some way. So for example, an example of that would be something like an if statement. You have an if statement with a then and an else branch, and for some reason you decide the code would be tidier or more readable with those inverted. So you can just say, okay, swap those two around. And IntelliJ will swap the two blocks around and invert the condition for you. And again, it's a small thing. It's something you could easily do by yourself, just changing it, but it's actually provided as a sort of single operation. And these things are context sensitive, so you don't have to remember 1,000 different keystrokes rather, to know how to do this. It just says, where you are, you're on an if block, you might want to change the if block in this way, and you can just do it. So the net effect of this, when I'm actually programming Java with IntelliJ, is that I get this very direct experience where I feel like I'm actually directly manipulating the syntax of my program while I'm working on it. And this is actually quite a powerful experience, I think. No other tool that I've used has really given me this, where I actually feel like I'm directly manipulating the structure of my program because the editor provides me with semantic operations that directly reflect what I conceptually want to do to my program. And this, I think, is really important. You can really get very, very deeply into the flow of programming when you like this, because a lot of the extraneous kind of complication is taken away. So this doesn't always come for free, right? I mean, these indexes and things, they take memory. IntelliJ can be quite a lot more resource hungry than other editors. And sometimes it can slow down while it's indexing and all these sorts of things. But when the stars align, which with IntelliJ they actually do pretty frequently, it's actually pretty good, it can provide a very direct connection to your program that I think that I haven't really managed to achieve with many other tools. And so this is always what I'm actually trying to get to with Cursive, and I'm a really long way away from doing it, mostly because it's just me, and they have teams of dozens of people working on these IDEs, and it's just a lot of work. But at least I always have very clear that that's actually the goal of what I'm trying to achieve. So this is something I see quite a lot online. IntelliJ is great, but I type much faster in Vim or Emacs or Sublime Text or whatever it is. And I think this is a bit misguided. I think if you need to type really quickly, then that means you're actually manipulating the text. And if I'm in IntelliJ, I don't really have to type very fast. And I don't have a problem with typing, to be clear. I mean, I know how to type, and I can type quite fast. But if I have to type a lot in order to program, it feels to me like I'm working at the wrong level of abstraction, because I'm not giving semantic commands to the editor to reflect what I want to do. I'm having to actually do all the nitty-gritty details myself. So I think lack of typing is really a feature rather than a bug, I think. I just think text manipulation, directly manipulating the text, is the wrong level of abstraction. And so for those of you who have actually who have edited some Lisp code in something like Emacs, for example, or another editor that provides this, you might be wondering about Paredit. So for those who aren't familiar with it, Paredit's a minor mode in Emacs, and it allows you to provide kind of block operations on languages that work with S expressions, so languages that are built up as sequences of lists and things. So you can move the last element out of a list, or drag the next element from outside the list into it, or you can replace the parent of a list with the contents of that list and that sort of thing. The problem with it is that it's not really syntax aware. So again, Paredit doesn't really understand Clojure. So you can use Paredit with Racket, with Common Lisp, with Emacs Lisp, or with Clojure. And it works equivalently with all of them. But it works equivalently with all of them because it doesn't really understand any of them at any fundamental level. So Paredit will happily let you bump a catch block out of its containing try block, for example, because it doesn't know, right? It doesn't know that a catch block makes no sense outside of its try block. It doesn't really understand the semantics of what you're doing. So I think of it in English as equivalent to ending all these sentences with full stops. I mean, you have to do it, right? And in Clojure or something similar, you have to balance your parentheses. But it's not really the most interesting thing. It's not really the most interesting problem we're trying to solve here. So there is a tool for Emacs called CLJ Refactor, which provides some of the sort of functionality I'm talking about for editing Clojure code. And that's much closer to the kind of functionality that I think we should be going to. But there's one interesting thing to notice about it in the name. It's CLJ Refactor. So this sort of tooling has to be specific to the language, because extracting a function in Clojure is very different to extracting a function in Emacs Lisp. So these tools do have to be language specific. And this is something else I see, never send an IDE to do a programming language's job. And I think that this is something that comes out of people's kind of visceral distaste for Java. And really most of the complicated IDE functionality out there is for Java these days. But I think, again, editor functionality, the sort of functionality I'm talking about, is kind of orthogonal to the language, right? I definitely think we should be trying to make more expressive languages and more sophisticated languages. But I'd say that they're not a solution on their own. I mean, obviously they're a great improvement, but I actually think that more sophisticated languages could probably even benefit more from this kind of editor functionality, but just because there's a lot more operations you could perform. And I think the main reason that this support doesn't exist for more languages is just that it's really, really hard to develop. It's just a ton of work. But that's actually distinct from it not being desirable. So I think a lot of people tend to think, well, this kind of support doesn't exist for my favorite language, so that's probably because my favorite language doesn't need it. And I suspect it's really because it's just really hard to develop for your favorite language, and it would be very useful if you had it. So I'm going to make a shameless appeal to authority here. For those who don't know Olin Shivers, he's been around forever in the scheme world. I object to doing things that computers can do. And so do I. I would like my editor to do all of this, and I'd like the editor to do all this for my users as well. So there's one big thing about indexing surface source code syntax that, that we need to talk about, and that is macros. So for those who aren't familiar with Lisps, the whole promise of Lisps, really, or one of the main things that distinguishes Lisp from other languages, is that this idea that they can be programmable programming languages. So Clojure code, like most Lisp code, is actually represented using the data structures of the language itself. So that means that you can trivially read in a chunk of Lisp code, and you'll just get back a bunch, well, in Clojure's case, you get back a bunch of like lists and maps and vectors, and that actually represents the program's source code. And so Clojure code is always compiled, even when you're doing it interactively at the REPL. So the way it works is the code is read in, and then before it actually gets compiled, Clojure will go through, and all the macros are actually expanded out. And so what's compiled, there's really only a handful of built-in forms in Clojure. And so you can use macros to just like add a little bit to the language syntax, or you can change the way the language works in really quite fundamental ways. So here's a little example, a transcript of a simple REPL session. So we just start up our REPL, and then we make this def macro call. So if you're not familiar with Clojure, don't worry too much about the details of what this is doing. But essentially, we're defining a new macro called for each, right? Because I miss my Java 5 for each when I'm programming in Clojure. And then I call it, right? For each x and 1, 2, 3, print it out. And 1, 2, 3, there it is. But what's really interesting is we've actually extended the language syntax there. And this macro use actually contains these two x's here that are highlighted, and that's a new local variable. So an IDE, to provide support for this, is going to have to understand what that means. It's going to have to understand that x is a local variable. It's going to need to know what its scope is. It's going to need to know which of these is the declaration and which is the usage. And in Clojure, most of the core functionality of the language is actually provided by macros. So things like def and let, these aren't actually built into the language as such. They're actually macros that expand out to the really core forms of the language. And Cursive really has no way to actually look inside these macros to see which symbols they define. And there are some other tricky cases as well, like symbols defined by macros may not actually even exist in your source code at all. So here's an example of that. So def record is a built-in Clojure macro that just defines essentially like a simple struct or something. So we're defining a point here that has an x and a y component. And then we call this arrow to point function, and that actually creates one for us. So that's a constructor function. So if you look at the name of this thing, the def record macro, what it actually does is it expands out into code, so the code that actually goes off and creates the record itself, but then it also creates a constructor function that you can use to create instances of this new type. But the name of that function doesn't exist anywhere in your source code. So if the user tries to rename that, what should you do? Should you allow them to rename it independently of the record itself? That doesn't really make any sense, right? So really, what Cursive does in that case is if you try and rename the constructor function, what it will do is it will rename the actual record, and that will sort of implicitly rename the constructor function. But there are lots of tricky cases like this that macros make quite difficult for editor support. So the first thing everyone says when I talk about this problem is why don't you just expand the macros, right? It's easy. So the problem is that macros in Clojure are completely arbitrary code. So a macro is literally just a function that accepts a little bit of program and returns another little bit of program back, and the bit you return gets used in place of the original, right? So this is a CL style, common Lisp style def macro. So it might never terminate, and you can't determine ahead of time whether it's actually going to. That's the halting problem. It might use a huge amount of resources. It might take for ages. It might use a lot of memory. And again, it's arbitrary code. It could format your hard drive. It could connect to your database. It could send rockets to the moon. You don't really know because it's not a pure language, right? And this list is actually taken from, directly from my issue tracker. I didn't actually write these. So there's a guy called Francesco below me, and he has this project called CLJ. And what that does is it takes a bunch of libraries from the Clojure ecosystem, and it indexes them and cross-references them. So you can see how they're used. You can see which libraries are used by which other libraries and where the functions are used and so on. And he doesn't have a static analysis engine like Cursive does, so he just expands the macros out to actually do his analysis. And he said that the first two there, macros never actually terminating and just hanging, or macros using a lot of resource, he's actually seen those, seen real cases of them in real code, and he sees them quite frequently. And in fact, I was at a scheme workshop a couple of years ago talking to people about this, And someone there told me about a macro that during macro expansion would shell out to a C compiler to parse a header file, and based on the contents of the header file, it would generate a bunch of code. So please don't ever do that, but people do this. And it's also very difficult to relate the macro expansion back to the source, right? So you expand all your macros, you get this huge ball of code, and it's very hard to actually relate that back to the original source often. So the trivial cases are usually pretty simple, but the complex cases get very hard very quickly. And so cases like that virtual symbol, for example, if you just naively expand a def record and you end up with this new symbol, there's really no good way for Cursive to actually know what that represents and what you should do if the user tries to manipulate it. So the solution I went for on Cursive is actually Cursive has an extension API, basically. So what this really means is I basically have to teach Cursive about macro forms so it can understand them. So when it sees something that looks like a macro form while it's analyzing its code, it looks at the head symbol, and if it has support for that macro, then it will call the extension, which is just a function, and that will return some data to Cursive that it will actually use in its analysis. So my plan is to open source this API and to open source the current implementations for various boring reasons. I haven't done that yet. But at that point, users will be able to add support for the macros, either that they develop themselves or that they use, so that Cursive can understand them better. And so there's all sorts of things. I won't go through that whole list, but there's a lot of different aspects of the way macros work that can be customized in this way. So a really good question, a question I should actually ask myself more often or more frequently with this, is what would Racket do? So for those who aren't familiar with Racket, it's a scheme implementation. It's been around for a really long time. It's used a lot in education and in programming language research. And interestingly, it comes with an IDE. So it's interesting to compare what Racket does compared to what Cursive does. So Racket in the editor does actually expand macros. And you can see there's some interesting examples here. So here's a little snippet of scheme code that defines a distance function. It takes 2 points, P1 and P2. And Racket is actually able to say, well, OK, this element in the source code is a usage of this parameter, P2. Even more interestingly, it has this PT, which is, again, is a point kind of data structure. And that creates these accessor functions, PTX and PTY, which you can see there. And it's actually able to say, well, the PT part of PTX comes from the name of the point structure, and the X and Y comes from the component name. And this actually requires interaction from the macro itself. So the macro itself, as it's producing the forms that it returns after the macro expansion, it actually uses a system called syntax properties to annotate them, to say this part of this symbol comes from over here, this part of the symbol comes from over here. Here's another example. So they've defined a myLetRec, which is just to replace the built-in scheme letrec, and they're using it to define a factorial function. And Dr. Racket can actually determine that from the definition of the factorial that the two uses actually relate to that definition. But the really interesting thing about this is that in the macro expanded code, the name fact doesn't appear anywhere at all. So, and I don't fully understand how this works, but basically as Racket is doing its macro expansion, it maintains the whole history of the macro expansion, and it's able to actually analyze that information to work out how the elements in the surface syntax relate to some later point in the macro expansion. It's really very clever. It's surprisingly impressive. So the advantages of this, obviously, are that many macros just work out of the box. You can add a new macro, you can immediately use it, and it will just work, assuming you're not doing anything too crazy. And in cases where it's difficult for the IDE to just do that, the macros can communicate with the IDE using these syntax properties. So they can annotate the various forms that they return in different ways. So they can tell the IDE to add tooltips on particular forms and things like that. But it does have some problems as well. So I asked on the Racket mailing list about this a while ago, and they went off and did a couple of tests. And so a 3,000-line macro-heavy file, which is not totally crazy in a big system, takes about 8 seconds to macro expand. So that means you open your file, you have to wait 8 seconds to be able to really do anything in your editor. And additionally, every time you make a modification to your file, it has to go off and do that again. So after every sort of edit in your file, you're waiting 8 seconds before you can do anything again, which is it's kind of a non-starter, I think, in my opinion. Memory use is also an issue. So again, like from a 3,000-line macro-heavy file, the macro expansion is going to be absolutely enormous. And Racket also tracks all the history as it's doing all these macro expansion, and that's more stuff that has to be stored in memory. So, I asked them about this, and they said that Dr. Racket is a memory hog, but they don't really know where all that memory is going. It's hard to say how much of it is due to this. And Cursive would actually have to macro expand in many more situations than Dr. Racket does. So things like indexing, it would have to macro expand in those cases. And Cursive actually can't macro expand during indexing because the index data, there's a really strong invariant that index data must depend only on the contents of the file being indexed. And if you're macro expanding, then that's not the case, right? It depends on the definition of the macro and the file itself as well. Also, Racket's macro expander is much more sophisticated than Clojure's, and so they have all these abilities to annotate things. Clojure provides something along those lines, but Clojure macros are pretty notorious for dropping metadata on the floor during macro expansion. And then finally, Dr. Racket in the Racket world is totally ubiquitous, so if a macro doesn't work with Dr. Racket, you can pretty much assume that the macro author will just fix it so it does. Cursive isn't ubiquitous, and in fact, there are a bunch of core macros that wouldn't work without this sort of support. So I can't really rely on that. So while the Racket solution is actually really nice, I don't think it will ever actually work for Cursive, unfortunately. So if you all take one thing away from this talk, I'd like it to be this. I think that when we're editing our code, I think we really should be working directly on the structure of our programs. I think our editors should provide semantic operations to us that allow us to directly manipulate our programs in sophisticated ways. That means that those tools need to be language aware. They need to be specific to the particular language that you're working on, and they need to provide manipulations that are specific to that language as well. And this is hard work. It's really difficult to implement this sort of thing, but it doesn't mean it's not desirable. I definitely think that most languages could benefit from this. And I guess many of you may go on to design programming languages for fun or profit, and I would ask you to do this. Try and bear this sort of tooling in mind when you're designing your language. So make them easy to parse, keep the semantics relatively simple and relatively obvious. Ideally, develop the tooling in lockstep with the language, and that'll help keep you honest. Thank you.